All right, let's take a look at this last problem here. All right, so this last problem wants us to determine the time domain capacitor voltage. So it wants us to find Vc of t. Okay. So in order to do that, let's take a look at what we have. So we need to first convert everything into the impedance forms. So let's do that. So Z of L is going to be J omega L. So J omega. Let's look at our V of S. So red flag, there's a sign right there, so that needs to be changed. So our V of S is actually 10 cosine 1000 t minus 90 degrees. Okay. Where our omega is 1000 radians per second. Okay. So 1000, and then L we said was 0.1. So when we do that, we'll get J 100 or 100. That's odd. 100 at angle 90. ZC 1 over J omega C, or negative J over omega C, negative J over 1000, 10 microfarads. When we do that, we'll get negative J 100. All right. So now, if we want to find what the voltage is across here, across this capacitor, we know that these two branches are going to have the same voltage. So we can do a couple things. We can either find the current that comes down through here, or something else, which requires less steps, is we would take these two, combine them in parallel, and then do a voltage division. And that's what we're about to do. So in order to do that, we need a loop. So we need to get the R and C into one equivalent piece. So Z parallel is going to equal ZR times ZC over ZR plus ZC. We're multiplying in the top. And then, apologies, Z of R is equal to 100 or 100 at angle 0. So 100 at angle 0, Z of C. This is also 100 at angle negative 90. So this is 100 at angle negative 90. The bottom here we're adding, so let's use the rectangular form. Plus negative J 100. Okay, so we'll have 10,000 in the top at angle negative 90. And then we'll have 100 minus J 100. Okay. I'm going to leave it to you to actually practice converting those in the bottom. So we'll carry our converting those over to the phasor because we're about to divide, so we need phasor. Negative 90 degrees, then 100, 141, 42, at an angle of negative 45 degrees. So 10,000 over 141.42. Negative 90 minus negative 45. And that will give us a ZP of 70.71 at an angle of negative 45 degrees. which is the same thing as saying 50 minus J50. Okay, so now that we have that, our new circuit looks like draw a box here. Call that ZP, and this will be L up here. This is the voltage source. All right, so all we'll do is just do a voltage division. So I'll write V of the parallel is equal to Z of the parallel over Z total times V of S. So Z parallel over ZL plus ZP times V of S. Okay, so Z parallel we said was 70.71, an angle negative 45 degrees. And the bottom Z of L is going to be J100 plus 50 minus J50. Our voltage source, so voltage source is going to equal 10 at angle negative 90. So 10 negative 90. All right. And we're just going to multiply the top. 7.071. And we're going to add those angles together. So negative 45 plus negative 90, so negative 135. And down here at the bottom, this will be 50 plus J50, which 50 plus J50 is just going to be 70.71 at a positive angle of 45 now. 7.71, angle negative 135 degrees. This will be 70.71 at an angle of 45 degrees. So dividing those out, 707.1 over 70.71, negative 135 minus 45. Therefore, voltage of P, which is equal to voltage of C, is equal to 10 at angle negative 180. Okay? Volts. So if we write that out, V of C of T will equal 10 cosine 1000 T minus 180 degrees. Volts. There we go. And comparing that to what they have, it's very close. All right. Well, I will see you in the next video. Yeah.